Hello folks, welcome to the second class of the Basics to Advanced series in the topic time, speed and distance. In case if you have missed the first class, do visit the first session, have one quick look at it and then come back to this class for a better understanding. Now we'll be talking about relative speed and effective speed for this session. Along with that, there's a couple of layers to it. We'll also be talking about problems based on trains and then boats and streams. So these are two concepts that use relative speed and effective speed extensively. Let's have one look at it. But before we get to boats and streams and the trains problem, I want to understand what relative speed is. What is relative speed? It simply says it's the relation between two speeds here. Now all this while in the previous class we talked about one object moving for a particular distance. Now relative speed happens when there are two or more objects, typically two objects, but then there can be cases of three people doing it parallelly. So relative speed is the relation between two speeds here. So to give you some context, let's say there is a distance of 10 meters between two people A and B. Right. Now if I say A travels at a speed of 3 meters per second, our minds would automatically say time taken to cover the distance will be 10 divided by 3, which is 3.33 seconds. That's simple. But then let's assume that B is also moving. Now if B is moving, will it be 3 seconds, 3.3 seconds to reach? Definitely not. What will be the time taken then? Now you cannot be certain of what time it will take. Even if I say, let's say B takes 2 meters per second as a speed. It travels at a speed of 2 meters per second. Can you tell me what time they will take now? Even now it is slightly tricky because I want to know one more information here. In which direction is B moving? That is also important, right? So which direction can he move? So when we solve questions of this type, we say there are two cases that we are looking at. One, either in the same direction or in the opposite direction. There are two cases, right? So let's say B is traveling in the same direction. Whatever direction is A moving, B also is traveling in the same direction. Now in this case, what will be the time taken? How do we understand the formula here? Of course there is a formula, but then let's not jump into the formula straight away. Let's understand the logic behind it. So what I want to think is, in 1 second, let's say if A alone had moved, for 1 second, if A alone had moved, what will be the distance between A and B then? In that 1 second, A would have traveled 3 seconds, so 3 meters. So the distance between them would have reduced by 3 meters. Yes. So the distance would have been 7 meters here, isn't it? This distance would have been 7. But in that same second, B has also moved. B has moved in the same direction and he has moved away from A by 2 meters. So the actual distance between them would be 9 meters, right? So when A moves 3 meters, the distance would have been only 7 meters between them. But B is also traveling 2 meters away from A. In that case, the distance between them becomes -3 plus 2. Or the distance between them would be 9 meters. Now from 10 meters, in 1 second it has reduced to 9 meters. If I do it for one more second, from here he would travel another 3 meters. This guy would travel another 2 meters. So the gap between them would have become 8. 9 minus 3 meters, but plus 2 meters, it would have become 8 meters. Now from here we can understand that for every second, the distance between them reduces by 1 meter per second, right? For every 1 second that I look, the distance between them reduces by 1. Or I can say the relative speed is equal to 1 meter per second. If it keeps reducing by 1 meter every second, what would be the time taken? Time taken would be 10 divided by 1, that would be 10 seconds. If I want to put it in an algebraic way, in a formulaic way, the time taken will be, the 10 happens to be the distance divided by, what is the time take? How did we get to 1? 3 and 2, the difference between them is 1, right? The difference between 3 and 2 is 1. Or I can say the difference of their speeds, I'm going to go very specific and say S1 minus S2. Not going to say difference between their speeds. I'll tell you why. S1 minus S2 and very specifically S1 greater than S2. Why am I not saying it? The difference between their speeds? Simple reason. If they had been running in the opposite direction, B chasing A, the difference of their speeds would be 1 meter per second. But imagine this. B is chasing at a speed of 2 meters per second. A is running ahead at a speed of 3 meters per second. Will B be ever able to catch A? Definitely no. So I don't understand the idea of difference when it comes here. I'm not going to stick with that. So I'm going to say S1 minus S2. Very specifically S1 greater than S2. Who is S1? The one chasing, the one who's running behind is S1. If S2 is chasing S1, that can never be caught. A will never be caught, right? So that's the understanding, S1 minus S2, and this happens when running in same direction, right? So this is going to be running in the same direction. What would be the other case then? If I say same scenario, A running at 3 meters per second and then B running at 2 meters per second. Distance between them is 10 meters. Then what would be the time taken? Simple. Every second, the gap between them reduces by -3 here, -2 here, or effective difference that I'm saying, effective reduction in the distance is 5 meters per second. A reduces it by 3, B reduces it by 2, or the relative speed here, relative speed will be equal to 3 plus 2, that's 5 meters per second, or I can say time taken is 10 divided by 5, that is 2 seconds. Once again, in a formulaic way, we can say T is equal to D divided by S1 plus S2 running in the opposite direction. Right. So two important ideas: relative speed when two people are running in the same direction, and then running in the opposite direction. If they are running in the opposite direction, you add the speeds, chasing one after the other, running one behind the other in the same direction, you take the difference, again S1 minus S2. That's the idea that we need to understand. If we understand this, a lot of questions on relative speed gets a lot easier. This is going to be the fundamental of relative speed. Stick with this, get a proper idea about this, so that when you solve questions, you can automatically start applying those values. Now, if I move forward and then talk about effective speed, what is effective speed? Effective speed is nothing but the effect of one speed over the other. I usually give this example. I tell when A and B were running in the previous case, the speed of A was not affecting the speed of B. The time changed. There was a change in time. The time got affected. But A changing the speed or B changing the speed did not affect the other person's speed. But when it comes to effective speed, one speed has an impact over the other. Where can I take this example? In a real-time example, we can think about an escalator. The easiest example that I give is escalator. So imagine there is a regular staircase that you can climb, right? And then there are two escalators, one escalator that goes up, the other escalator that comes down. Now you want to go up. Which is the easiest mode to go up? Obviously the escalator that is going up. Why? The staircase will take some time, which is fine, but the escalator, you don't stand on an escalator. Sometimes we happen to walk on the escalator, so you have a speed of going up. The escalator is also giving you a push. In that case, your speed technically increases. Now you would not walk on an escalator that is coming down. The escalator is coming down, you will not walk on that. Why? You have to increase your speed to reach in the same time, and also there is a lot of pressure on you. We don't do that. This is one example. The other example where you get extensively questioned is boats and streams. Imagine there's a boat and then there's a stream, a water body, a flowing water body. Now water body always flows from higher level to lower level, right? So water is flowing. Water can flow in only one direction, from higher level to lower level. But what can a boat do? It can come from the top to bottom or go from the bottom to top. It can travel in both directions. Now in both directions, the time taken to cover the same distance is not same. Why? When you are coming down, the water is also giving you a push. It's giving you more speed. That way you reach your destination a lot faster than going up, because there is a force against you. It is reducing your speed, and that reason tells you that you cannot go in the same time. Now these are what we call it as two cases. One is called as water is going down and then the boat is also going down, and then water is going down but then the boat is going up. Now if I have to say the speed of the boat is u and then the speed of the stream is v and the distance that the boat covers is d. Now in this case, will I reach faster or slower, quicker or later? Obviously I'll reach quicker. Simple reason, I'm getting a push. The speed of the stream is getting added up to my speed, or the time taken here is equal to d divided by u plus v. And this is under the condition downstream. And then this is under the condition, in this case, if this is u and this is v, t is equal to d divided by u minus v. Right. So this is called as upstream. Right. So we'll have to understand, okay, when the water body is flowing down, it always flows down, and the boat goes in the direction of the stream, it's called as downstream. Sometimes they will not say from top to bottom, they will say against the flow, with the flow of the water, with the current or against the current. So we understand, with the current is similar to downstream, against the current is similar to upstream, not similar, that's synonymous to upstream. So when the boat goes in the direction against the flow of water, that's u minus v. Speed of the stream reduces your speed. It's going to be u minus v. When the speed of the stream is adding up to yours, or the boat travels in the same direction of the water, the speeds gets added, and that's called as downstream. So again, effective problems, boats and streams have a lot of questions on effective speeds. We need to get that. Now the question that I usually get is, okay, effective speed is used in boats and streams. Where is relative speed used? Relative speeds are used everywhere, but then the common place where you get relative speed is problems based on trains. Train traveling, crossing something, crossing a pole, platform, train, bridge, tunnel, car, lorry, it could be anything. In those cases, problems, relative speed comes into picture. Now the first thing that I would think is, if there is a train that's traveling in a certain direction and then there is a man standing here, figuratively speaking. Now what will be the time taken by the train to cross the man? To understand that, I want to think about what is crossing a man here. Now when I say there is a train that's standing and then a man crosses it, what do you mean by crossing a train? The man starting from the end of the train, from one end of the train to the other end of the train. So the time taken by the man would be length of the train divided by the man's speed. Alright. So when a man crosses a train, we say length of the train, time taken is equal to length of the train divided by man's speed. Now the man is stationary, the train is moving. So what is the distance to be covered? It is still the length of the train. Now man, if there is a man, there is a pole, there is a milestone, there is a bike, the length of whatever that we just mentioned is negligible when compared to the length of the train. So when a train crosses a man, we also take the length of the train here. There's no other length. When a man crosses a train, distance is length of the train. When a train crosses a man, distance is still length of the train. So T is equal to D by S, where D is length of train and then S speed of train. Now, what about the other guy here? The man, the milestone, a lamp post, a stone, a car, a bike, unless or until there's nothing mentioned about it, those distances are negligible. You don't really worry about, oh, what is the length of the man. Even if the man is lying down, the man lies down, that's 1.5 meters on an average, 1.7 meters. Trains will be 250 meters, 150 meter long trains, 100 meter long trains. This 1 meter, we really don't worry about it. It's negligible. But what if a train is crossing a platform or a tunnel or a bridge for that fact? Now, when will I say the train has crossed? If the train starts, this is the train and this is the platform. From this point, where the beginning of the train is at the starting point of the platform, until we go here and then the train reaches this spot. The back of the train is at the end of the platform. So that's completely crossing the platform or a bridge, whatever it is. So what is the distance that should be covered by the train? The train should cover its own distance through the platform or whatever it is. In that case, what will be the time taken? T is equal to d1 plus d2 divided by s, where d1 is equal to length of train, d2 is length of platform, tunnel, whatever it is, and s is speed of train. Right? S is going to be the speed of your train here. These three parts we are done. But then it could also be another train, right? It could be a length of a platform, length of a tunnel, length of a bridge, it could be a length of another train. But under this condition, this pretext, what do we understand? The other train is stationary. The train is not moving. Now comes the question, what if that train is also moving? In that case, we'll have to understand two trains are moving. So what will be the time taken? The immediate question that we need to ask is, in which direction this train is moving? Why does it matter? Absolutely. Imagine this. Two trains are traveling the same direction. It will take more time, right? We all have done this in our childhood. If there is a train that's going the opposite direction, when you look through the window, it will be super fast. You will feel like the train crossed you in a jiffy. Why is that? Because they are traveling the opposite direction. You are coming in a speed and that's going in another speed. It feels like the speed has increased. But when you are traveling along in another train, you will be able to see every single passenger sitting in that train, no matter what the difference of the speeds are. That's because it matters. The speed matters and also the direction of the train matters. If there are two speeds, once again, we introduce the idea of relative speed. So in that case, T is equal to d1 plus d2 divided by s1 plus or minus s2. Why am I saying plus or minus? Simple. I don't know what direction it is going. If it is the same direction, s1 minus s2, opposite direction, s1 plus s2. Right? So d1 is equal to length of train 1, d2 length of train 2, s1 length speed of train 1, and then s2 speed of train 2. Right? That's all. But then I understand if this is a train that is moving, two lengths come into picture, two speeds come into picture, but this will be for what happens when a train is traveling, the time taken to cross a man. Same idea, the man has a speed, but the man does not have a distance, a man or a bike or whatever it is, negligible distance, that does not have a d2. In that case, t is equal to d by s1 plus or minus s2. Bunch of ideas. We might feel like, hey, there's way too many formulas here. In reality, they are not formulas. The simple idea behind that is, okay, I'm going to stick with this concept. I'm going to apply it logically. The more you understand it logically, the better we get at it. We'll apply this to a set of questions and then we'll see where it takes us. So we'll quickly solve 3 questions. We'll have a set of questions and then we'll see whether we can apply that idea and get through with it. So to solve the first question, two trains of lengths 120 meters and 180 meters are moving in opposite direction at speeds of 38 kilometers, 36 and 54 kilometers per hour respectively. How many seconds will they take completing to cross each other? So two trains traveling in the opposite direction. So time taken will be d1 plus d2 divided by s1 plus s2. Opposite direction, speeds gets added. So what is d1 here? 120. d2 is 180. So d1 plus d2 is 120 plus 180 divided by s1 is 36 kilometers per hour, s2 is 54 kilometers per hour, but the distance is given in meters. We cannot take the speeds to be in kilometer per hour. So I'm going to convert it. So relative speed is 36 plus 54. That's 90 kilometers per hour into 5 by 18. This is 5 into 5, that's 25 meters per second. Substitute the value of S1 plus S2 as 25. We'll get 300 divided by 25. 25 into 4 is 100, into 3 is 300, that's 12 seconds. Had they been traveling in the same direction, this would have become S1 minus S2, 54 minus 36. But this question, same direction, so we are adding it. So be very particular about what condition we are working with, right? A train 150 meters long is running at 54 km per hour. It crosses a man walking at 18 kilometers per hour, walking in the same direction. How many seconds will the train cross the man completely? So there is a train that's 150 meters long, traveling at 54 km per hour. A man walking in the same direction at 18 km per hour in the same direction. How many seconds will it take? So here dt is equal to d divided by s1, same direction, train crossing the man. So it's going to be s1 minus s2. So substitute the values. Length of the train is 150 divided by s1 minus s2. S1 is 54. Train is crossing the man. So 54 minus 18. Relative speed is equal to s1 minus s2. That's going to be 54 minus 18. That's going to be 36 kilometers per hour into 5 by 18 will be 10 meters per second. So if it is 10 meters per second, the time taken would be 150 divided by 10. It will be 15 seconds. So these are basic funda when it comes to relative speed and effective speeds. So hang on, get that idea before you jump on to intermediate and advanced level questions. That's important. We'll do one more question. A boat travels 30 kilometers downstream in 2 hours and the same distance upstream in 3 hours. Find the speed of the boat in still water and the speed of the stream. So we have to find speed of boat, speed of stream. Let's find them both. Downstream, we know time taken in downstream is equal to d by u plus v. D by u plus v, right? Time taken in upstream will be d by u minus v. So let's find it. We have been given the distance is 30 kilometers per hour. Time is given. So let's substitute it. D divided by u plus v, or rather than d, let me straight away substitute the value here. 30 by u plus v is equal to 2, or u plus v is equal to 30 by 2, that is 15. Call it equation 1. 30 by u minus v is equal to 3, or u minus v is equal to 10. Call it equation 2. Solve both equations. u plus v is equal to 15, u minus v is equal to 10, 2u is equal to 25, u is equal to 12.5. So substitute u equal to 12.5 in this. 12.5 plus v equal to 15. V is, that will give us v is equal to 2.5 kilometers per hour. So speed of the boat is 12.5 kilometers per hour. Speed of the stream is 2.5 kilometers per hour. And that's your values. So plug it in, understand what condition it is working around with. The moment you get it, we fly with it. So in case if you understood all these concepts, try solving this question. A nice idea. It's a question on trains. There's two conditions given. Have a look at it. If you have gotten the answer, do drop your answers in the comment box. And then in case if you haven't joined our Telegram channel, those are the QR codes. Scan that. Join those channels. Any discussion, anything that we do here, if you have doubts, feel free to shoot your questions there. We'll solve it. All the best.